So today I want to talk about the technical architecture of Meter and how we are obsessed about every detail, like Anil mentioned. And then what does vertical integration mean for us? So as Anil mentioned, the company is built with vertical integration in mind. Why did we do that? We did that because we care about outcomes for partners and for customers. Great outcomes matter a lot. And what are these outcomes that we care about? Quality of install, quality of deployment, um, having customer onboarding that's easy, that's seamless, and detecting issues and alerting on these issues so that we can fix the network very quickly, and feedback from our partners and customers, and taking this feedback directly from you and then integrating into our product and having rapid innovation. That makes a huge difference for us. And I'll talk about why we can rapidly innovate because of the architecture that we have. So what are the ingredients for having great outcomes? The ingredients are hardware, software, and operations. And what I mean by that, this is we have a tight feedback loop between all three. So we take hardware, we make it better, and then because of that, we make our software really good. And once we make our software really good, we make our operations really good. And then once we make our operations really good, we take that back into our software and then build features. And because of how the breakthroughs that we have in our software, we go back and we redesign our hardware to make it better. It's a complete loop that we maintain constantly throughout the company. And one of the key components of Meter, the way that we have our teams built is also vertically integrated teams. It's tightly integrated. So given those are the ingredients, what is the formula? And part of the formula for this is our technical architecture. And here, I want to talk about our data plane, our control plane, our virtualization layer, our management plane, and our application layer. And for each part of the stack, the four core tenets that we pay attention to and constantly try to improve our performance, security, scalability, and reliability. And that's through every part of the stack. So as we go through this, I'll talk about our performance, our scalability, and security and reliability as well, but just pay attention to each one of the components that I'm going through. The first one I want to talk about is our data plane. And our data plane consists of our hardware platforms. And we have 5 hardware platforms, 4 are our core, and one platform is the observers. And for our hardware platforms, we have security appliance, which has SD-WAN, firewall, routing, you name it. And then we have switches and access points, and then PDUs. So all of these are built for performance, and we've taken specific deliberate approaches on which part of the stack we want to optimize. And we do specific data plane optimizations for each one. And as you can see, we have a chart for performance, and you can see that our access points compared to other vendors, how they perform. They are better at sometimes, and even close to some of the best performing hardware out there. The other performance I want to talk about is our security appliance, our network performance overall. So one example of that is our auto VPN, site-to-site VPN. So we have our own site-to-site VPN between our security appliances, our networks. And as you can see, the performance compared to any other vendor. So we do almost line rate speeds on our base model security appliance, which is a 1 gig security appliance. And we have 2 models today. And in the future, we can talk about our 2025 plans of the hardware that we're going to release and how they perform.
I'm not sure if you can disclose this, but how are you achieving that? Is that just raw? Is it you just put big ass CPUs in there, or is it that you're using a different transport protocol?
Yeah. So we have a different transfer protocol that we built on top of, and we optimize in our data plane. Our data plane is completely different from the normal data planes.
Okay.
Yeah. So we use something called user space networking, and we bring everything into our user space, and we optimize there. So we do not throw large CPUs at it. That's not efficient. That's not optimized. So that's a data plane.
Another question, Scott Robon.
Yeah.
And I meant to ask you this weeks ago. Why include your PDUs in this part of the discussion? That's interesting.
Yeah.
So you can turn it off and back on again.
Well, that's a good point. So
solve all network problems.
Again, it comes down to operational efficiency. We've seen with customers when we deploy these networks, many times ISP modems don't perform the way they do. They have buffer overflows. They have to be rebooted. They have a lot of issues sometimes, right? So how do we go ahead and make sure that the networks can be restarted remotely and not have a truck roll? That's expensive, right? It's time consuming. It's manpower. It's a lot. It's a lot of things. So what we have done is every single hardware is cloud managed, including our PDU. So how do we achieve PDU cloud management when an ISP goes down? So we have LTE module built into our security appliance. So even if all ISPs go down, the LTE kicks in and you can remotely manage the entire network. And the LTE is only used for management today, not the data plane. And in 2025, you'll start to see that you can use our LTE for data plane as well.
And I mean, that's absolutely critical, right? Because what's the first question that every ISP asks when you call in an outage ticket, right? Have you verified power to the site?
Yeah.
And then have you rebooted the CPE? Right?
Exactly.
So you being able to do that out of band
Yes.
and essentially before you're even reaching out to the ISP, right? I mean, that it shortcuts that and gets it squarely into them to start dealing with, right?
Yeah, absolutely.
And I'm assuming you're on as part of the offering here. I mean, you're on the hook for really managing that ISP in terms of resolution, right?
That's right.
So you're really enhancing your own efficiency in mean time to resolution.
Incentives.
Yeah. Yes.
For us, we have to do better, right?
Right.
So one of the ways you'll see our data plane built out is you can have, at least for this model today, you can have up to 5 ISP connections. It's all SDN. So our data plane is all SDN. So you can have up to 5 ISP connections today if you wanted to, right? Given that, let's say all ISPs go down, you still have LTE on the back end.
Yeah, and in most physical environments, they're all going to go down at the same time anyway.
Exactly. So how do we achieve our data plane cohesiveness? And when I talk about operational efficiency and also rapid innovation, how do we achieve that? And we do that with our network operating system. It's a unified image that's built for all of our platforms. And the reason we designed it is, again, to make sure the networks are up and running at all times. How do we do this? So with network operating system, you can upgrade and downgrade a network with a click of a button. So we have a security appliance, switch, and an access point and PDUs. All of them are related with each other. So when we release network operating system, it's one image. So it gives us the advantages to upgrade and downgrade in the entire network with single click of a button. It reduces or eliminates completely any interoperability or config compatibility issues. And then it also helps us have great firmware release process, which I'll talk about next. One of the ways that we use our network operating system is the way that we collect data from our devices. This is a existing average meter network. You can see it's 274 access points with some 3,600 clients. And you can see that we collect 1.5 billion data points from the network. And that's only possible because of the way we designed our network operating system. Every single platform is unified. Network operating system also allows us to build something we call as SAMs. It's a security protocol and exchange protocol that we built internally. What this means is as soon as you plug in a meter device onto a meter network, it knows that it's a meter device, and it knows that it's a meter network. So what it does is it exchanges information over IPv6 neighbor discovery protocol, very high level, but we can talk about it later. It exchanges information about each other, and it gets IP information as needed. What this means is our networks are immune to rogue DHCP attacks. That's one example. So they sit above the DHCP layer. So that's another advantage of network operating system.
Hey, sorry to jump in. Can I ask a quick question?
Yeah.
It's Malcolm here.
Yeah.
When you put a meter network in, so like you've got multiple different devices, do they have to be directly connected to each other? Or could you have meter device, something else, meter device, and does it tunnel over the top or something like that? So just to your point that you said, when you connect a meter device into a meter network, if there's an intermediary step, can it handle that?
Yes, absolutely. Because of the multicast protocol that we use, you can have any other device in the middle. It's not a problem.
Okay.
Yeah. So with network operating system, the advantage of firmware release process is very apparent for us, because when we release the operating system, the network operating system, we go through multiple stages. And one of the key points here is, because it's one unified image, we're able to test it very robustly. And when we do release our operating system, you can be sure that it's fully compatible with the hardware and no issues in the field. Again, that comes back to operational efficiency. You don't want to bring down the networks. So given this, we have the process here. You can take a look at this. The interesting thing is we dog food our networks. And there's been many times during the testing, I knew something failed because my wife texts me saying, internet is down. Is it even working? So it's like taking a dagger, twisting my heart. So it's a constant thing where I get a real life feedback very, very quickly. So you don't want to bring down your home networks. That's the worst thing. So we have our dog food networks, our beta, our release candidate, and it's like a cycle process that we go through. And everybody in the company goes to the dog food network. So it's a good feedback for us. The next thing I want to talk about is the control plane. So as you've seen, the integration of the hardware and then the network operating system, it enables us to build the control plane in sort of a malleable way. We can design our features very quickly. And our control plane is an example of that. We have SD-WAN, we have firewall, we have role-based access control, we have ATS and ATX, automatic channel selection, automatic power selection, and so on and so on. So I'll go through the dashboard when I bring up a live network here today, and I'll go through some of the features. I won't be able to cover everything that we have today, but after the session, you can come play with the dashboard and the product. So you'll get a chance to see everything. So how do we bring all of this together, and how do we make sure that the deployments are great? What we have done is, in this layer, we've done something called a virtualization layer. We've taken our hardware and modeled it in our backend. So what this means is you can set up the entire network without ever deploying a single piece of hardware. You can virtually set up the entire network. It comes back to, again, learning from operations and our partners. How do we best enable them to have great tools so that deployments go better and better and better? So with the virtualization layer, you can go ahead, set up the entire network. You can set up multiple networks, as many networks as you want. It doesn't matter. And once you set it up, you can set up the configuration. You can set up the SSIDs, firewall, whatever you want. And then once the hardware is connected, it goes and contacts the backend and downloads the right configuration. Before the configuration hits the hardware, we validate that. That's the layer that we validated. And that's why it's so powerful. So the configuration, bad configurations are never sent to the device. And hopefully, as we get better and better, we'll catch that even faster and faster. So that's one way for virtualization to help deployments. The other way is, let's say you want to swap hardware or upgrade the hardware. You don't really have to think about upgrading the hardware. You can literally go in, take the hardware out, put the hardware back in, that's it. And the virtualization layer takes care of deploying the right configuration to the hardware. Hopefully today I can demo that if you have time, because I don't want to miss the command demo. So I have a lot of things to cover. Those are the few things that the virtualization layer really help us deploying great networks. And how do the devices, the operating system, the control plane all communicate to the backend? It's through our secure tunnels. So we use TLS 1.3 and AES 256 encryption for every single communication. Given that each of the device communicates directly to the backend, everything is a complete different node onto the network. So you can revoke access, you can provision a device all separately. Next is the management plane. So the management plane is where we do all of our stats, so metrics, stats about the devices. We have our HA built into it for our cloud architecture. We have observability pipelines, and this is where we can scale pretty much as big as we want here. And the management plane also has security and authentication built into it. So today you'll see on the dashboard, we have SSO, single sign-on, role-based access control, directory sync, everything built into the management plane. And you'll also see that because of the management plane, the way we've designed and architectured our backend, we can take that and build more applications on top. This is one of the main reasons that command is possible for us. And I would love to go more deep into this after this session, and I can show you how we built all this. So given all of the stack below this, we are able to achieve observability at scale. So billions of data points from a single network, and constantly understanding the network and making decisions. And building applications and products such as Connect, Meter Connect. So we take the ISP procurement and we just feed that into our data pipeline as well, which means a Meter customer, we know what the ISPs are, we know how they're performing, and then we know what to recommend. So if an ISP is not performing well, we can go to the customer and say, hey, we have monitored for 90 days or 120 days, and we've seen that this network is not performing great. I think we think we should go to another network. And we will suggest that, and they can just buy the ISP connection right in the dashboard. I'll go through the Connect dashboard as well today. And then building the dashboard itself. Because of the virtualization layer, everything is API for us. And I'll go through some of the logs that we have. Every single change you make is logged as an API request. That allows us to build dashboards the way that we are building today. We are our own consumers of our API. And then last thing is command. After my demo, Anil will come back and then go through the command demo, and he'll talk more about how we're building our own models internally and how we're using the entire architecture that we have designed over the past 8-9 years, and how command is possible. So that is the Meter architecture. Any questions?
Yeah. So digging into the guts a little bit here.
Yeah.
What do you use for your switches and for the security appliance? Do you use the same packet processing complex? I'm assuming you're doing it's off the shelf or commercial silicon, right?
Yeah, commercial silicon.
So who are you using? What's the guts?
We partner with Intel, Marvell, and Qualcomm today.
Okay.
And we use those chipsets.
Got it.
Yeah.
Okay.
And the data plane is our own for the security appliance. We've designed it from ground up at Meter.
You designed what?
The whole data plane.
Okay.
Yeah, we wrote it and built it at Meter.
Okay. It's not an ASIC though. I mean,
it's not an ASIC.
Okay.
Intel.
Oh, got it. Okay.
Yeah, it's an x86.
Got it.
Yeah. Any other questions before jumping into the demo? I think the next one is demo.
Yeah. Just a question about, I guess, I don't know if this is the right place to ask it, but just around like your billing models. So for customers that have multiple business units or push cost center cost down to individual locations who have to pay for their own. Like, do you have ways that you can sort of partition or multi-tenant or segment a customer's environment?
Yeah, you can segment customer environments as however you want.
Okay.
And you can also give access to different environments. So let's say you are you have a company that has 300, 500, or even 2,000 locations.
Mm-hmm.
And you have a team, and you want to say this team only has access to East Coast networks or West Coast. You can partition them. You can give access to them.
And if each of those 300 sites is kind of responsible for their own networking costs, you can kind of handle that. Give them the ability to sort of choose. Maybe they want a high availability or a less available.
Yeah, of course.
Okay.
Yeah.
And one other question, this is Steve. How does this look like in the big picture? Obviously, in the large organizations you're talking about, you're not the only network there. Do you have a 10,000-foot view of how the integration and compatibility works in the larger team, or is that coming later?
No, I can show it to you. I don't think we have the slide, but just a high level, you have multiple topologies, right? So let's say it's a very large organization, and like you were saying, if you have a Palo Alto network, what we do is the Palo Alto networks can be as a bump in the wire, or they can be the firewall, and then we can have our firewall switches and access points downstream of it. But let's say you have an organization where you have data centers or you have POPs, right? Mm-hmm. So the way you can work with that is we have IPsec built into our stack. So you can have a branch meter, and then you can connect to your POP through IPsec, and then you can have the entire connections there. So all meter branch offices or locations can connect to a POP, and you can have a Palo Alto in the POP, and then we can just connect via IPsec.
And then how does it work with the coordination of the troubleshooting, across those boundaries and things? How does the integration of the operations work?
Yeah. We don't integrate with Palo Alto today directly in our dashboard, but because everything is cloud managed for us, you'll have a single view for all meter networks. So
Mhm.
from a meter networks perspective, it's quite easy. You go to the dashboard, you can see all your networks. I'll show you, it's a hub. You can see all the meter networks with ISPs, with devices functionality, uptime, everything in one place. But we don't integrate Palo Alto into it. So you need to have another dashboard for Palo Alto.
And I assume you have an API on that, so the NOC that's sitting over this entire mess can query in and put it on their master dashboard, that sort
Yeah,
of thing.
that's coming in 2025. Yeah.
How about like IaaS cloud? So do you have like a virtual security appliance that you can run in AWS or Azure or whatever in order to sort of enable, if you've got a situation where you've got really zero on-prem
Yeah.
application environment, you're 100% cloud.
Yeah.
Do you have like a virtual, excuse me, a virtual SD-WAN
Not
appliance, something like that? Okay.
Not yet.
Okay.
But we're thinking about it. We want to hear from our customers and our partners to see how we can design this.
Okay.
So we don't have that today.
Okay.